So today we're going to talk about derivatives of cosine, sine, e to the x, and natural log. So these we need to memorize, and we will be adding them to our things we need to know form. But the derivative of sine is cosine. And the derivative of cosine is negative sine. So there's a proof of the derivative of sine here for those who are interested, following that limit definition of the derivative. But what I'm more interested in is us using these derivative rules. So if I were finding the derivative of 2 sine x, well, that would just be 2 and then times the derivative of sine. So dy dx would be 2 cosine x. Now this one is sine x over 2. That's really 1/2 sine x. So the derivative would be 1/2 times the derivative of sine, cosine. Now here, remember, we can separate it out, take the derivative of x plus the derivative of cosine. So the derivative of x is just 1, and the derivative of cosine is negative sine, so 1 minus sine x. Next, the derivative of e to the x. This is why we really love e to the x. The derivative of e to the x is e to the x. It's beautiful. So the derivative of 5 e to the x would be 5 e to the x. The derivative of e to the x is e to the x. The derivative of negative 4x is negative 4. Now let's put them all together. So we've got 7 e to the x plus cosine x. So that's going to be 7 e to the x. And then the derivative of cosine is negative sine x. All right, now let's look at natural log. So the derivative of ln x is 1 over x. So I've got 3 ln x. So that's going to be the derivative of y with respect to x is going to be 3 times ln x becomes 1 over x. Then I've got negative 2 e to the x. Well, that's just negative 2 e to the x. And then negative 1/2 cosine x. So negative 1/2, the derivative of cosine is negative sine. So let's simplify that a little bit. 3 times 1 over x would be 3 over x. And then negative 1/2 times negative sine would be plus 1/2 sine x. Now, what if it's not ln? What if it's a different log? Well, if it's a different base logarithm and we take the derivative of it, what we end up just kind of adding in is 1 over ln of that base, the natural log of that base. And I really don't want this to be kind of something you have to memorize. So let's just think about the fact that we have this change of base formula. Log base b of x. We can rewrite that as ln of x over ln of the base. So if I take the derivative of that, well, ln b is just a number. So this is like taking the derivative of 1 over ln b times ln x. 1 over ln b is just a number. So when I take the derivative of that, it would just be 1 over ln b times the derivative of ln x, which is 1 over x. That gives me ln b times x. So recall that we have these different ways we can write the limit definition of a derivative. We could have x plus delta x or x plus h as that difference in x's, or the h goes to 0. We could also write it at a point and actually have a specific x value. So c plus h or c plus delta x. Or we could write it in more of the slope form, f of x minus f of c, x minus c. So recognizing these limit definitions is a really important task. So let's see if we can recognize what this is taking the derivative of. Well, the function is sine x. So the function is sine x. And we're taking the derivative at a specific x value. That c, that x value, is pi over 3. So what this is really doing, this really means to take the derivative of sine at pi over 3. So we're finding f prime of pi over 3. Well, the derivative of sine is cosine. And cosine of pi over 3 is 1/2. On this next one, ln of x minus 1 over x minus e. This kind of reminds me of this setup. Let's see if that really is true, because it should be f of x minus f of c. So what's being plugged in as c? It looks like c is e, and that my function is ln of x. Let's see if that's true. What would be f of c? Well, that would be ln of e, which is 1. So that is true. So this is finding the derivative of ln of x, at e. Okay, so the derivative of ln of x is 1 over x. So this is 1 over e.